So today we will start the second last section, or you can say whatever you want to say, chapter. I think section, you better say that. So section for this course, and that is basically magnetism and electromagnetism. Now, what is this electromagnetism and magnetism? Let's talk about this. So basically, what exactly is the situation here? Firstly, magnetism. Now, what exactly is magnetism, right? When you say magnetism, it means something related to magnet, right? So, what exactly is the situation? A magnet is a basically instrument, you can say, or magnet is a conductor or a metal, whatever. It attracts things made of iron, nickel, cobalt, steel, and their alloys. So, a magnet is always uh, occur in the form of oxides and mixture of magnetic oxides. So what does it do? It attracts these kind of materials: iron, nickel, cobalt, steel, whatever you want to say. A pure magnet, when you talk about a pure magnet, it has two poles. One pole is called as a north pole and the other pole is called as south pole. Now, what and how do we actually find out those north pole and south pole of a magnet? Once you, I mean, get the pure magnet out of its oxide and all that. So, what exactly is happening? You just hang it in the air with a thin wire or whatever. Okay. When you do that, what will happen? We know that Earth is behaving as a magnet as well. So, Earth has a north pole and a south pole. Now, what happened when you actually hang that magnet, right? The side or the position which hang or which leans towards the north of Earth is a south pole of a magnet, and the side which is lean towards the south pole of Earth is a north pole of a magnet. So that's how you found out the north and the south pole of the magnet. Excuse me. Now, once you have those south and north pole, right? Now, what exactly will be the situation? You got north pole and you got south pole. Now, if you bring another magnet near to that, interesting fact is what we have noticed, that two opposite poles, they attract each other. Like north and south, they will attract each other. North and north will repel each other. So north and south or south and north will attract. And same thing, north and south will repel each other. So this is what the point is. Like poles repel each other, unlike poles attract each other. That's what we have seen. Now, once you understand with this small concept, you need to understand one more thing. There is a small difference between magnet and magnetic material. Magnetic material means magnet is a thing that attracts. Magnetic material is a thing that is being attracted, right? So what is the difference? For example, this is a magnet having a north pole here. You bring any material, you don't know it's a magnetic material or a magnet, you bring it here. And let's suppose it is being attracted. Fine. It can be a magnet, can be a magnetic material, but cannot be a non-magnetic material. Now you change the position and then bring it near to the North Pole. If it's still attracted, it's a magnetic material, because magnetic material in any case, whether you change the sides or whatever, it will be attracted by the magnet. As far as magnet is concerned, if you bring one side nearer, if it's attracted, the other side must be repelled. Then and only then you can say that this is a magnet. So, magnet and magnetic material, right? Now, a magnet has a magnetic field around it. That is very interesting. Magnetic field is an area around a magnet in which a magnet will attract, or you can say repel, the other magnet. And this magnetic region can be shown in the form of magnetic lines, which are starting from the north and ending at the south, like that. It is shown by arcs like that. The arrows shown that it goes from north to south like this. Right? So basically, that's like this. So basically, started from north and ending at south. This region is a region in which you can say another magnet is being attracted, or magnetic material will be attracted. Now, if the concentration of line in a certain area is more, that means strong magnetic field in that area, right? If the concentration of magnetic field is less, definitely the weak area, right? So if you're bringing any magnet or any magnetic material far away from this magnetic material, or far away from this magnet, the magnetic line concentration will be lower and lower and lower and lower. And if you bring it closer and closer and closer, that will be strong magnetic field. How do you show it? More lines, magnetic lines, right? Understood one thing, that these lines will never cut each other. Okay, these lines will never cut each other. Now, once you understand by this, now magnetic material can be made magnets, right? And some magnetic materials have a tendency to become permanent. Now there are two things. Remember that there are two kind of magnets. One is called as permanent magnets, and other one is called as temporary magnets. Temporary magnets are the magnets which become magnet for a small period of time, and then they become again magnetic materials. Permanent magnets are the magnets which are magnet. If any magnetic material turns into permanent magnets, the magnetism will lose after a very long period of time, or in other words, you can say maybe magnetic material will not lose, and it will turn into permanent magnet. Now remember that a magnetic material can convert into magnets, first of all. Now there can be multiple way, rubbing and all that, but we here are talking about new small continuation topic, which is called as electromagnetism. Now, when you say electromagnetism, as the name suggests, electro means electric current. So you pass a current, and that turns a magnetic material into a magnet. That is what we called as electromagnetism. A magnetism which is produced due to electricity is called as electromagnetism. And those magnetic materials which turns into magnets due to electricity is called as electromagnets. Now, there are two type of electromagnetism. One is called as hard magnetic. As far as magnetic materials are concerned, there are two divisions for that. One is called a soft magnetic material, and one is called as hard magnetic materials. Soft magnetic materials are the, you can say, materials that are soft, first of all. And once the electricity is passed through them, they convert themselves into temporary magnet for a small period of time. And once you remove the electricity, they will again turn into magnetic. As far as hard magnetic materials concerned, they have a tendency to become permanent magnet. Once the current passing through them, they will turn into magnet, and once the current is removed, they will remain magnets because they have a tendency to become hard magnet once the electricity will pass through it. The example for the soft magnets, magnetic material is iron. Once the iron become magnet, after some time, the magnetism can be lost. The example for the hard magnetic material is steel. Once the current is passing through, and once it's removed, they turn into permanent magnet. So, electromagnetism, soft magnetic material and hard magnetic material. Now, once we understand that soft magnetic material and hard magnetic material, we will especially focus on electromagnets. Magnetism due to, you can say, electricity. Now, we will start from very basics. What exactly is what? Now, let's see that. That's the first small topic out of that. Now, check this out. This is very interesting. Let's take a wire. Now, as I told you, we are not working on the permanent magnets. Remember that. Hard magnetic. We are always talking about a soft magnetic material because a soft magnetic material can be used for different purposes. Because it will be a temporary magnet, and once we want to use them, we will use it, and once it will turn into again a simple magnetic material. So let's suppose this is a wire and it is connected to a battery. Once it passes through the battery, once the current is passing through, you can see that a magnetism is produced within the wire. Now, that magnetism will be either a clockwise or either the anti-clockwise, depending on the shape. Check this out. What we have noticed that once the current is coming like this, we called it in the upward direction from here to here. The magnetic field will be in anti-clockwise direction. So, if the current direction will be in opposite direction, the magnetic field will be clockwise. The circles are showing that. Now, if you check one thing out, the dot represents the current flowing upward. Now, remember that whenever the current is flowing in the upward direction, we called it current up. Dot means out of the page. Upward. This dot means out of the page. And these circles are showing the magnetic field, which are concentrating to this circle. So this is in anti-clockwise. So when the current is out of the page, the magnetic field is anti-clockwise. Circles are showing anti-clockwise, right? And when the direction is changed, it will be into the page. You can check this out. That cross means the direction will be into the page. And the circle shows clockwise. So cross means into the page, the direction of a current, and circles will be anti-clockwise. In this case, the magnetism shows anti-clockwise direction, right? Now, how to increase that magnetism? So magnetic field circles can be increased by increasing. The field is strong close to the wire, we know that. How to increase it? You can increase the current by increasing increasing the current will increase the magnetic field lines. Magnetic field technically, right? Now, how to give this? How will you find out? For that, we have a Fleming right hand rule. Now, if you check this out, Fleming right hand rule, that's very interesting. Grip the wire like that, and this is the direction of a current. If this thumb is the direction of a current, that curling finger will give you the direction of a magnetic field, and this shows anti-clockwise. So if it means that the current movement is in upward direction, the fingers are showing anti-clockwise magnetic field. Remember that we always take the direction of a conventional current, the positive current, right? This is called Fleming's right hand rule. Now, this is a thing called solenoid. Now, what is solenoid? You can see it's a wire, a thick wire with a curlings in it. Now, what happened when the current is passing through these curls, these windings, each winding behave as a single conductor, a single wire. So in that case, the magnetic field effect will be increased. That device is called as solenoid, right? So once the solenoid is connected to a battery, now that solenoid, you will have one side as a north and one side as a south. Now this is very interesting. If the current is going through this is, you need to understand. Now this is important. If you see the current is coming from positive, you're considering like this. This is anti-clockwise movement, right? Anti-clockwise. So if current is like this, the direction of the magnet or magnetic field which is produced, the direction will be north on the right and south on the left, right? The direction you can see by looking at these circles that starts from north, south and ends at south. Even the lines are passing through the center as well. Now, this is similar to the magnetic field, except in the middle, the lines are also passing. Now, there can be number of turns if you increase it. The magnetic field is increased. The current is also one of the cause to increase the magnetism. Now, the point is how to find out this direction thing, north and south, right? This is called a right hand grip rule. Now, what exactly is this? Check it out. Now, if you see that, now this is very interesting. You will understand it. If this is the wire, for example, and current is going this way, anti-clockwise. Now, this way the current is going, so your fingers will curl in this direction. So, anti-clockwise. So, basically, right hand grip rule means anti-clockwise. So, current, if this direction, for example, you will grip like this, because in this case, the north will be this. My hand will curl in this direction. So, it's going this way, like this. So, my hand will be in this direction. So, this thumb shows the north and definitely the other side will be the south. If the direction will be like this, for example, this direction means this will be in this, then this way. In this direction will be the north and this direction will be the south. So technically, the finger curling will tell you everything. In the downward case, if you see here, the current is going this way. That is a direction. Now this direction will be like this. My hand will this way. So thumb is showing the direction of a north, while south is the direction of the, thumb is the direction of a north, hence definitely the other direction will be the direction of a south. So this is how they developed it. Once you found out where is north, where is south, and then simply draw the, magnetic field line that started from north and ending at south. Okay. This is called right hand grip rule. So basically, I've shown you with the left hand. Actually, it should be from the right hand like this. So basically, in that case, check it out. So it goes this way. So there is one. And if it goes this way, which is from south to north, for example, if it goes this way, then it will be like this. And if it goes this way, it will be like this. So it's a right hand. We can give from left hand as well, but we normally use the right hand grip rule for that. Okay. So right hand grip rule will be used to find the direction of south and north in the solenoid. Right. Now, next topic is basically, our next topic is, not circuit breaker is not a part of us. Magnetic storage is just an example for that. We have a sort of a magnetic wire placed within the magnet, right? This topic we will start in the next class. That will be the end of our lecture number 29. In this lecture, what we have covered: magnets, electromagnets, hard magnetic material, and soft magnetic materials, and the magnetic field within the wire and the solenoid, and right hand grip rule, and left hand Fleming left hand rule. That's what we have covered up. In the next classes are very important. In those classes, we will cover up how the magnetic wire, or how the what will be the principle of motor is actually. This is the basis of principle of motor, and then definitely we have left out transformer and everything. So hope to see you in the next lesson. Thank you very much. Thank you for watching my video. Bye.